Okay, Algebra 2 classes, it is my understanding that you are covering adding, subtracting, and multiplying polynomials. I believe yesterday Mr. Marks went through adding and subtracting. I will go over a few adding and subtracting, not a lot of them, and I will continue on to multiplying polynomials. I just want to warn you, first of all, that I may use different terminology from what Mr. Marks uses, so I'm not trying to confuse you. It's just the way that I was taught and the way that I teach my students with these type of vocabulary terms that I use. Nevertheless, they're probably synonymous and mean the same thing to what Mr. Marks has introduced to you, so please don't get confused. Learning the different ways that something can be named is a very good thing, so just make sure that you are aware that I may be using different words, different terms, but they mean the same thing. Alright, so first of all, we have this example up here. 2x cubed minus 5x squared plus 3x minus 9 plus x cubed plus 6x squared plus 11. Obviously, we're adding. How do you know that we are adding? Well, because we see a big old plus right there in the middle. If we look at this polynomial right here, let's recap. Let's recap. What degree is this polynomial? Well, this degree is going to be 3. Remember that the degree of a polynomial is the highest exponent that you see. And in this case, it would be the 3 over here. So this is a cubic polynomial. Here in this part, we are missing some terms. However, the highest exponent would still be the 3, so that means this is still a cubic polynomial as well. All right, so I know that some of y'all are very visual people, and this is what I tend to do in my class, and this is a good opportunity if you have different colored pens or highlighters, or even if you have a pencil, it's fine. You can do it with different shapes and things like that. I like to kind of color code each of these terms so that you can be able to solve this. All right, so the way that I do it is I'm going to say, okay, I'm going to add like terms. So I see a cubic here. I'm going to box that in red. And then I see a cubic here. So I'm going to box that in red as well. Even though you don't see it, there is a number in front of this x cubed, and that's a 1. So I'm going to squeeze it in there so that you can see it for those visual people. And all I'm going to do is just I'm going to combine those two boxes, those two red boxes. 2 plus 1 is equal to 3. So we're going to have 3x cubed. All I do, or all I combine, is the coefficient of each one. All right, I'm done with that one. Let's move on, and then after, or once you count down from the third exponent, you have the second exponent. So right here is 1 with the power of 2, and then right here is the other one with the power of 2. So we have a negative 5x squared plus 6. That's going to leave us with a positive 1x squared Then after the second power, we go to the first power, which it looks like it's right here. We have this. And if we go over to this polynomial, there isn't one. So we just rewrite it. So it's going to be, it's like saying 3x plus 0. And anything plus 0 is itself. So we're left with just plus 3x. And then finally, we have the constants left. So we have a negative 9 plus 11, and that will give us a positive 2. Okay, so if we clean this up the more traditional way that you're going to see it, you're going to see it as 3x cubed plus x squared plus 3x plus 2. This is the way that I typically like to show my students how to add polynomials. Moving on to subtracting polynomials. So I'm going to move on to example 2. Example 2 says 8x cubed minus x squared minus 5x plus 1. That's all one polynomial. And just for review, what degree is this polynomial? 3, very good. Minus, and then we have 3x cubed plus 2x squared minus x plus 7. Okay, the first thing that I want to do is distribute this minus sign to everything after it. That's the first thing you want to do, distribution. Alright, so from there we end up getting, we can just copy this down without the parentheses. So we end up getting 8x cubed minus x squared minus 5x plus 1. And then let's go ahead and distribute. Minus 3x cubed minus 2x squared plus x minus 7. Okay, so then we just combine like terms. So again, this is a good time for you, if you want to color code. So I have the cubed here and the cubed here. Now the tricky thing is you need to make sure you're also taking the coefficient as well as the sign in front of the coefficient, whether it's a minus sign or a plus sign. So we have 8x cubed. The way that you read this is 8x cubed minus 3x cubed. That's going to give us 5x cubed. Okay, and then we have the squares after that. So we have negative x squared minus 2x squared. So that's really saying there's a negative 1 here that you're not seeing. So I'm going to squeeze it in there. So really what this is saying is negative 1 minus 2. That's going to give you a negative 3x squared. Then we move on to the x's. So we have a negative 5x plus x. There's a 1 here that I'm going to squeeze in that you're not seeing, so I'll put it in there. And it reads as negative 5 plus 1, and that's going to be a negative 4x. And then we're left with plus 1 minus 7, or in other words, 1 minus 7, and that's going to be a negative 6. So our answer for this one is 5x cubed minus 3x squared minus 4x minus 6. Okay, so this is subtracting. The key thing here is to basically distribute and then combine like terms. Okay, we're going to now move on to multiplying polynomials. And we're probably going to start with something simple. Something that you have seen in Algebra 1. So this is example 3. And let's start off with something that is going to be x minus 7 and x plus 3. Let's do that. Alright, does anyone remember what concept from Algebra 1 am I going to use to multiply these two binomials together? Alright, hopefully in this classroom someone said FOIL. If someone did say FOIL, that is correct. We're going to FOIL. So we're going to say first, so that's x times x, and that's going to be x squared. Then I'm going to say times the outer. So x times a positive 3 is going to be a positive 3x. Then the inner. So negative 7 times x is going to be a negative 7x. And then the last. A negative 7 times a positive 3 is a negative 21. I don't know if you've noticed, but this is basically you multiplying. And then from here, you traditionally would combine like terms. The only like terms that combine are these two in between. So you have x squared, and then a 3x minus a 7x is a negative 4x, and then the rest, minus 21. Okay, this is something very simple, but in Algebra 2, of course, I believe you have already studied higher degree polynomials. You have looked at quadratics, cubics, quartics, 5th degree, 6th degree, 7th degree, 8th degree polynomials. You've looked at their end behaviors. Where does it start and end graphically? And hopefully you've seen the roots or the x-intercepts or the solutions to these. Now we're going to have larger polynomials. No longer you're going to have something this simple like x minus 7 times x plus 3. Now you're going to have something bigger. So let's go ahead and move on to example 4. Okay, so for example 4, we are going to have x plus 3 times 3x squared minus 2x plus 4. I have a feeling that my 15 minutes are going to be up in a little bit. So if it ends, someone or the sub, just go ahead and click on to the next video and we'll pick up from there. Alright, so the FOIL concept still remains the same. You have to multiply the first term times everything in the second terms, and then here you're going to have to do the exact same thing. So whatever you're basically going to